In this experiment, we'll take a volatile liquid, we will heat it up until it turns to a gas and occupies the entire volume of the flask. We'll then condense it, let it turn back to a liquid, find its mass, find other data we need to solve for the gas laws, and solve for the molar mass. A flask that has a pinhole in the cover that allows the gas to escape as it's expanding. First, we find the mass of the flask before the volatile liquid is put in. We take a sample of the unknown volatile liquid, whose volume when it turns to a gas we know is larger than the flask. We pour our liquid into our flask. We set up a hot water bath and put the flask in it, so the volatile liquid will turn to a gas. We use a thermometer to measure the temperature of the hot water bath, so we know the temperature of the gas. We heat the water to boiling, allowing the volatile liquid to turn completely to a gas. We use boiling chips in the hot water bath to ensure even heating. After we see all the volatile liquid has evaporated, we allow it to keep heating. As the vaporized liquid goes up the tube, we can see it cooling and turning back to a liquid. We must continue heating until we're sure that there is no liquid remaining in the flask. We heat for a couple extra minutes to be sure there is no liquid left. After the heating is completed, we seal the top, here with parafilm, to keep out other vapors from the flask. Prepare a cold water bath. The cold water bath will cool the vapor, turning it into a liquid inside the flask. We let it cool while it is still sealed. We see the liquid collecting in the bottom of the flask. After it is cool and we're convinced it's all liquid, we unseal the flask to equalize the pressure. We then reseal the flask and dry the flask completely in order to find the mass of the liquid that's in the flask. We'll find the mass of the liquid by subtracting the mass of the empty flask from the mass of the flask with the liquid. It must be completely dry because it was dry when we started. Next, we must find the volume of the flask. If we know the volume of the flask, we'll know the volume of the gas that was occupying it. We completely fill the flask with water and then measure the volume of that water in a graduated cylinder. We must also know the pressure of the room, so we know the pressure of the gas in the flask. In order to do a calculation using the ideal gas law, we need to know the mass of the gas, the temperature of the gas, the volume of the gas, and the pressure of the gas. We can use the ideal gas law, rearranging it to solve for the number of moles of gas that must have been in our flask. Once we solve for moles, we can use the grams of the liquid that we had, which was the grams of the gas, and find the molar mass of the unknown volatile liquid.